welcome back to the physics classes. This is the fourth session of the ray optics and optical instruments chapter. Okay, now let's quickly revise the things which we have learned in the previous class. In the previous class, we had learned about refractive index. So there are two types of refractive indices. One is relative refractive index and another one is absolute refractive index. So this relative refractive index is a ratio of the refractive index of one medium with respect to another medium, and absolute refractive index is the ratio of velocity of light in vacuum to the velocity of light in the given medium. We have also discussed in the last class about lateral shift and normal shift. So this lateral shift means the perpendicular distance between the incident ray and emergent ray, whereas the normal shift means when you keep the object in one medium and a person is observing that object from another medium at normal incidence, the object which is in another medium appears to be raised. So this phenomena is called as the normal shift. Next, we had also discussed about total internal reflection. This total internal reflection is the phenomena where the light ray passes from denser medium to the rarer medium, and at an angle of incidence more than the critical angle, the incident ray totally reflect back to the same medium. So that is the total internal reflection. And we had discussed about the applications of total internal reflection. 4 applications we had discussed. One is the mirage, formation of mirage. This is nothing but an optical illusion produced in deserts due to total internal reflection. Then the brilliance of diamond, then total reflection prisms, and the last application is the optical fibers. So these optical fibers are nothing but thin strands used for the transmission of signals. Fine. And the application of the applications of optical fibers also we had discussed. The next thing which we are going to discuss today is about the refraction through spherical surfaces. Alright. So when I say spherical surface, refraction through a spherical surface means this is a part of a sphere which is solid. In case of reflection, we had considered a hollow sphere where inner side or outer side is coated. But here in refraction, we will consider a surface or we will consider a sphere which is solid. Okay. So here also in the case of refraction through spherical surfaces, you need to know some basics. That is the definition of aperture. The definition of aperture is the area which is available for the refraction is nothing but aperture. Next definition is of the pole. Like in case of reflection, which we have already discussed, the midpoint of the spherical surface. Spherical surface means it should be solid spherical surface is called as the pole. Next thing is center of curvature. So the center of curvature is represented by C, and it is the center of sphere of which the spherical surface forms a part. Next definition is of radius of curvature, which is represented by capital R, and it is the radius of the sphere which the spherical surface forms a part. Next one is the definition of principal axis, a straight line passing from the center of curvature and the pole is nothing but the principal axis. So these are the few basic definitions which we need in the ray optics, that is particularly in case of refraction. Okay. Now in this refraction, 5 marks question which they can ask is obtain an expression for refraction through a spherical surface. Now let's discuss about the refraction through a spherical surface. So as I said earlier, this derivation will be asked for 5 marks, and for this we need a spherical surface. So let us first draw a spherical surface. Okay, so I am drawing a spherical surface here. After drawing the spherical surface, draw the principal axis for this spherical surface. As you already know, the principal axis is a straight line passing from the pole and center of curvature. Okay. Now here what I am going to do is, I am going to place one object here. Okay. This is represented by O, and this object is placed in a medium of refractive index N1, and this spherical surface is made of a refractive index material N2. Now this object will emit light ray which will strike the spherical surface. Okay. So the light is incident on the spherical surface at a point N. Fine. Now as we already know, from one medium to another medium the light is traveling. What should happen here? It has to undergo refraction. So we have to draw now the refracted ray. Before we draw the refracted ray, we need to mark the center of curvature C. Okay, see, on the right side you will have center of curvature because the sphere will be formed on the right side to the spherical surface. Alright, now let's draw the normal first. Alright, so I am going to draw the normal now. It is a straight line passing from the point of incidence to the center of curvature. So this is the normal here. Okay. Fine. So this red line represents the normal. Now next, as the light ray is traveling from rarer medium to denser medium, this is a rarer medium and this is a denser medium I am going to consider. Fine. N1 is the refractive index of rarer medium, N2 is the refractive index of the denser medium. Since the light is traveling from rarer medium to denser medium, as you know, it will bend towards the normal like this. Okay, so it will bend towards the normal. This is the refracted ray, and here you will get the image I. Okay, so this is the image of the object. Fine. Now as we can see, here you have one angle of incidence. This is the normal and incident ray. In between there is one angle. So that angle is called as angle of incidence. Now this is the normal and this is the refracted ray. Here we will have angle of refraction represented by R. Fine. Now what I am going to do, I am going to draw a perpendicular here. Okay. So I am drawing one perpendicular here and I will name the point as M. Okay. Here you have pole. So this P and M will be very close to each other. Since both will be close to each other, instead of P I can consider M, or in place of M I can consider P, because the distance between them is very, very small. Now, the distance from the object to the pole, as you already know, is represented by u, and the distance between pole and image I is represented by v. Okay, and the distance between center of curvature and pole is represented by r. Okay, so this is our ray diagram. As you can see, the object is placed in a rarer medium of refractive index n1, and the image is formed. The image is represented by I, and the image is formed in a denser medium of refractive index n2. Okay, u represent object distance, v represent image distance, and r is the radius of curvature. I is the angle of incidence and r is the angle of refraction. Okay, the very first step for the derivation is considering Snell's law. Okay, now consider Snell's law. From the Snell's law, we know n1 sin I is equal to n2 sin r. Now here the angles are very, very small. Here the angles, for example, the angle of incidence, angle of refraction, etc. are very, very small. Okay, so if the angles are very small, this equation can be written as n1 I is equal to n2 r. So keep this in mind. In whole derivation, we are going to consider the angles which are formed here are very small. So we are going to neglect the trigonometric functions. We will just consider whatever is their angle, whatever angle is along with the trigonometric function. So here this sign I have ignored and I am going to take only I. So it is n1 I is equal to n2 r. Okay. Now let's proceed. I'll call this as equation number 1, which we have got from the Snell's law. So in this equation, we have to find out the angle of incidence and the angle of refraction. We need to calculate the values of I and r. Okay. So to find out the values of I and r, we are going to use the geometry. Alright. As you can see in the ray diagram, there is a set of triangles like this. I am going to redraw it. Okay. So this point is O, this point is N, and this point is C. Here you have angle of incidence I. So this angle we need to calculate. For the calculation of this angle of incidence, you need to use the definition of the exterior angle of a triangle. So for the triangle NOC, from triangle NOC, we are going to find out the value of I, angle of incidence. Alright. So for this triangle, this I is the exterior angle. The exterior angle value will always be equal to the sum of the interior opposite angles. Okay. So I can write I as equal to angle O plus angle C. Alright. And here there is another line like this. This point is M. Fine. So next step is to calculate O and C. From tan, trigonometric ratio, tan of the angle, you can calculate what is tan O. Tan O will be NM divided by OM. So angle tan O is equal to n m divided by O m. As I said already, the angles are very small, so tan O will be taken as angle O is equal to n m divided by O m. We have got the value of O, angle O. Similarly, angle C is equal to, the opposite side of angle C is nm. It is n m divided by C m. Okay. Now, angle O and angle C values should be substituted in this direction, which will give you I is equal to nm divided by OM plus the next thing is nm divided by Cm. So, this is our second equation. So, this equation is the value of angle of incidence. Okay. Now, let's calculate the value of R. As you can see here, R is here. Let me redraw this triangle once again. It is like this. Okay. So, this is R, this is N, and this point is C and this point is I. Fine. In the previous triangle set, we have used exterior angle definition, but here the exterior angle is actually angle C. So, what can be written here? We can write it as angle C is equal to angle R plus angle I. This is from the triangle NCI. Okay. Now, let's rearrange this because we need to know the value of R. R will be equal to angle C minus angle I. From these triangles, right angle triangles, let us calculate the angle of C and value of angle I. Angle C will be equal to Nm divided by MC. Observe here, this is angle C. So, for this angle, Nm is the opposite side, MC is the adjacent side. And next, I, angle I will be equal to, here you can see angle I. Angle I will be equal to Nm divided by Mi. M divided by Mi. Now, substitute these equations in this equation. So, R is equal to angle C is Nm divided by MC minus angle I is Nm divided by Mi. This is equation number 3. Alright. So, we have calculated the values of R and I. Now, we need to substitute these values in equation 1. Substitute equation number 2 and 3 in equation number 1. Okay. I will first write the equation number 1. It says N1I is equal to N2R. So, N1, the value of I is from equation number 2, it is Nm divided by OM plus Nm divided by Cm is equal to N2, write as it is. R is here from equation number 3, it is Nm divided by MC minus Nm divided by Mi. Okay. Now, you need to solve this equation. As you can see, Nm is on both sides. On the left hand side you have Nm, as well as on the right hand side also you have Nm. So let's cancel this Nm. Next, multiply this N1 with the bracketed terms. You will have N1 by OM plus N1 divided by Cm is equal to N2 divided by MC minus N2 divided by Mi. Now what I am going to do is, I am going to club Cm terms. Alright, here you have Cm, here you have MC, which is nothing but Cm. So I am going to take this Cm term to the right hand side, and I am going to take this term into the left hand side. So I will write N1 by OM, this negative will become positive, plus N2 divided by Mi is equal to N2 divided by MC minus N1 divided by MC. Cm can also be written as MC, no big major difference. Now it can also be written as N1 by OM plus N2 by Mi is equal to, since MC is common, N2 minus N1 divided by MC. Okay, this is equation number 4. So in equation number 4, as you can see, we know the value of OM. Here the value of OM is equal to U, object distance. The value of Mi is nothing but V, which is image distance, and MC is nothing but radius of curvature R. Now let's substitute these values in equation number 4. You will have N1 divided by U plus N2 by V is equal to N2 minus N1 by R. Now this is not the last equation, this is not the final equation. One more step we have to write, that is applying Cartesian sign convention to this equation. So here, as you can see, the light rays are moving in this direction. Okay, and as we already know, all the distances must be measured from the pole. Okay, so pole is here. The distance of object from the pole will be measured like this, towards the left. Okay, like this. So OM, image distance, will be negative. You have to write it minus U. Fine. Next, the image is on the right hand side and the light is also moving in the right hand side like this. So both have the same direction. So V will be positive and R is also on the right hand side. So R will also be positive. Now let's substitute these U, V, R values along with the sign convention with this in this equation. What will you have? U is negative, so minus N1 by U plus N2 by V is equal to N2 minus N1 by R. Since this R is the radius of curvature, okay, since R is the radius of curvature, that is also positive. Okay, so this equation is nothing but the refraction through a spherical surface equation, which says minus N1 by U plus N2 by V is equal to N2 minus N1 by R. Okay, so for this what we have to do? We have to consider Snell's law first. Okay, we have to consider the Snell's law, N1 sin I equals N2 sin R. And here, since the angles are very small, put it as N1I is equal to N2I. Next step is,
using the definition of exterior angles, or using the property of exterior angles of a triangle, you can calculate the values of I and R. Okay, so from these two sets of triangle we have calculated the values of I and R. Next step is substituting the values of I and R in equation number 1, and the rest thing is solving it. Alright, so once you solve everything, what should be done? You have to apply the sign convention and you will get this equation, that is n1 by u plus n2 by v equals n2 minus n1 by r.
So after this we are going to discuss about the lenses. Alright, so the lens is an optical medium bounded by two surfaces, and at least one surface must be spherical. So we have many different types of the lenses, as you can look at here. The first figure represents plano-convex lens, which means only one side is spherical. Plano-concave lens, biconvex lens and biconcave lens. So this biconvex lens is also called as a converging lens. Biconcave lens is also called as a diverging lens. Now let's discuss about the images in case of lenses. So as in case of reflection, which we have already discussed, images are of two types here. Real image, another one is virtual image. Okay. As you can see here, there is a ray diagram where one convex lens is used. So this h0 is the height of object, which means that is representing object, and the opposite side you can see h dash image. Alright. So here you can see all the refracted rays are meeting at a point. That point is nothing but real image. Next one is virtual image. As you can see here, we have taken an example of a concave lens. So here, if you take the concave lens, since this is a diverging lens, the light will not meet at a point after refraction. What we have to say here, the light ray appears to meet, because as you can see we have extended the rays back. So the point at which all the refracted rays appear to meet is called as the virtual image. Okay, let's revise the things which we have discussed today. We have discussed about the refraction through a spherical surface. Under that, we have discussed about few basic definitions like pole, principal axis, radius of curvature, center of curvature, and a pole. Okay, so these are aperture. We have also discussed about the aperture. Then we had discussed a 5 marks derivation regarding refraction through spherical surface. So this question will be asked, as I said earlier, for 5 marks, very important. And the case which we have discussed here is when the object is placed in rarer medium and the image is formed in the denser medium. Then we have discussed about lens and its types. So there are major two types of lenses, concave and convex. Then we can have plano-convex lens, plano-concave lens, etc. Then we had also discussed about the types of images, real and virtual images. In the next class, we will be discussing about 5 marks derivation, that is lens maker formula. Lens maker's formula, very important concept. So keep studying. Thank you so much for watching.